Welcome everyone to this workshop on Advanced Python for Data Science. In today's session, we will explore how Python has become one of the most powerful and widely used tools in the field of data science. This workshop is designed especially for those who already have a basic understanding of Python and now want to move to the next level. Throughout this presentation, we will focus on practical concepts, real-world applications, and tools that will help you build strong data science skills. By the end of this session, you will not only understand advanced concepts but also feel confident enough to start working on your own data-driven projects. Let's move forward. First is Introduction to Data Science. Data science is all about extracting meaningful insights from raw data, and it generally follows a three-step process. The first step is exploration, where we try to understand the structure of the data, identify patterns, and detect any anomalies or outliers. The second step is analysis, where we apply statistical methods and algorithms to draw conclusions and validate our assumptions. The final step is prediction, where we use models to forecast future outcomes based on historical data. Python makes all these steps easier because it provides powerful libraries and tools that simplify complex operations and allows us to focus on solving real problems. Now next move towards why Python leads data science. Python has become the leading language in data science for several important reasons. First, it is very easy to learn because its syntax is simple and readable, almost like English, which helps beginners quickly understand and write code. Second, Python has a rich ecosystem of libraries such as NumPy, Pandas, scikit-learn, and TensorFlow, which cover everything from data manipulation to machine learning. Third, Python has a huge community of developers who constantly share knowledge, tutorials, and solutions, making it easier to learn and troubleshoot problems. Finally, Python is widely used in the industry by companies like Google, Netflix, and NASA, which makes it a highly valuable skill for career growth. Now let's move on. Advanced concept overview. In advanced Python for data science, there are several powerful concepts that improve efficiency and code quality. Decorators allow us to extend the functionality of functions without modifying their original code, which is useful for logging or performance tracking. Generators helps us work with large data sets by generating data one item at a time instead of loading everything into memory. List comprehensions and lambda functions provide concise ways to write transformations and operations. Context managers ensure proper handling of resources like files or database connections. Multiprocessing and asynchronous operations allows us to execute tasks faster by running them in parallel. Finally, object-oriented pipelines help in organizing complex workflows into reusable and maintainable structures. Now, NumPy advanced operations. NumPy is the backbone of numerical computing in Python, and its advanced features make it extremely efficient. Broadcasting allows us to perform operations on arrays of different shapes without manually reshaping them, which simplifies calculations. Vectorization replaces slow Python loops with fast array operations that are executed at a much lower level, making the code significantly faster. Fancy indexing allows us to select and manipulate specific elements using arrays of indices, which is very useful when filtering or restructuring data. These features together make NumPy highly efficient for large-scale numerical computations. Now, Pandas data manipulation. Pandas is one of the most important libraries for data manipulation and follows a structured workflow. First, we load the data from various sources such as CSV files, databases, or Excel sheets. Next, we clean the data by handling missing values, removing duplicates, and correcting inconsistencies. Then we transform the data using operations like grouping, merging datasets, and reshaping tables. Finally, we analyze the data by applying statistical methods and extracting insights. This step-by-step process helps convert raw data into meaningful information that can support decision making. Now, data visualization, Matplotlib and Seaborn. Data visualization plays a crucial role in communicating insights effectively. Matplotlib is the foundational library that allows us to create different types of plots such as line charts, bar graphs, scatter plots, and histograms. Seaborn builds on top of Matplotlib and provides more advanced statistical visualizations like heat maps and pair plots, which help in understanding relationships between variables. While creating visualizations, it is important to follow best practices such as labeling axes clearly, choosing appropriate chart types, and using colors wisely. A good visualization can make complex data easy to understand. Now, working with large data sets. Handling large data sets efficiently is a key skill in data science. One important technique is chunked reading, where we process data in smaller parts instead of loading everything into memory at once. This improves performance and reduces memory usage. Another technique is optimizing data types by using smaller data formats like int32 instead of int64 when possible, which can significantly reduce memory consumption. When datasets are too large to fit into memory, tools like Desk and Wix allows us to process data in chunks and perform computations efficiently. This strategy helps us scale our analysis to handle big data. Now, machine learning with scikit-learn. Machine learning in Python using scikit-learn follows a simple and structured workflow. First, we prepare the data by splitting it into training and testing sets to evaluate performance properly. Next, we choose an appropriate model based on the problem such as classification or regression. Then we train the model using the training data so it can learn patterns. Finally, we evaluate the model using the test data to measure its accuracy and effectiveness. This process ensures that our model is reliable and performs well on unseen data. Now, feature engineering techniques. Feature engineering is a critical step that can significantly improve model performance. It involves transforming raw data into meaningful features. Encoding is used to convert categorical data into numerical form. Scaling ensures that all features are on a similar range so that no single feature dominates. Feature selection helps identify the most important variables for prediction. Imputation is used to handle missing values effectively. Binning groups continuous values into categories, which can reveal patterns. Interaction features combine multiple variables to capture deeper relationships. This technique helps create better inputs for machine learning models. Now, model evaluation methods. Evaluating a model correctly is essential to ensure its effectiveness. Metrics like accuracy, precision, recall, and F1 score help measure different aspects of performance. Accuracy shows overall Accuracy shows overall focus on specific types of errors. The F1 score balances both precision and recall. ROC-AUC measures how well the model distinguishes between classes. Cross-validation improves reliability by testing the model on multiple subsets of data. A confusion matrix helps visualize correct and incorrect predictions. Comparing training and testing performance helps detect overfitting, ensuring that the model generalizes well. Now, automation with Python. Automation allows us time to save time and make processes more efficient in data science. Instead of manually performing tasks repeatedly, we can create automated pipelines that fetch data, clean it, train models, and generate reports. These pipelines can be scheduled to run at specific times using tools like Schedule, Cron, Apache Airflow, or Prefect. Automation ensures consistency, reduces human error, and allows us to scale operations easily. It is a key step in turning data science projects into real world applications. Now, real world use cases. Data science is used in many industries to solve real problems. In banking, machine learning models detect fraudulent transactions in real time. In healthcare, data is used to predict diseases and improve treatment plans. E-commerce platforms use recommendation systems to personalize user experiences. In finance, algorithms are used for trading and risk management. Climate scientists analyze environmental data to study changes and predict future conditions. Social media platforms use sentiment analysis to understand user behavior and recommend content. These examples show how powerful data science can be in real life. Challenges and best practices. While working in data science, there are several challenges that we must handle carefully. Data quality issues like missing values and inconsistencies can affect results. Overfitting is a common problem where models perform well on training data but poorly on new data. Scalability becomes a challenge with large datasets, and choosing the right algorithm can be difficult. To overcome these challenges, we should follow best practices such as exploring data thoroughly using cross validation, documenting experiments, and starting with simple models before moving to complex ones. These practices help ensure reliable and effective results. Thank you for being a part of this workshop on Advanced Python for Data Science. The key takeaway is to first build a strong foundation before diving into advanced topics. Practice regularly using real datasets and platforms like Kaggle can be very helpful for gaining hands-on experience. Remember that the Python ecosystem provides all the tools needed for a complete data science workflow, from data collection to model deployment. Now it's your turn to apply what you have learned and start building your own data science projects. Thank you.